The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I know you all are doing good, safe at home, enjoying with your parents. Though I say the major part that you are missing your school life. Very soon we will meet children, and I'm so happy that most of you have sent your homework immediately, but there are some children still you haven't sent me. I don't want to say the names of those, but still whether it is right or not, you try to send the homework to your concerned teacher children so that we will learn the mistakes what we have done. Not only in my subject, also in the other subjects. Any subject teacher has given you a homework, don't forget to submit it on time, because that shows your attitude towards the subject. Okay, and I know my children are good and you will do that. Okay, children. See, last class we were seeing about empirical formula, percentage composition. I hope you are able to understand. Definitely once the chapter gets over, we will be doing the problems, 1 or 2 extra problems, so for us to have a clear idea about the topic. The next topic which we will be dealing with is the limiting reagent. Before that, we have something called stoichiometry calculations. Stoichiometry means something, a measure of the mass of the reactants and the products that are formed in the reaction. This we have done in 10th standard, if you remember, children, calculating the moles of the products formed with the amount of reactants available. So this I will be posting a video right now to you to understand about balancing the equation and how to calculate the stoichiometry calculations. So now you will see the video. After that, we will be getting into limiting reagent.
Balancing chemical equations. A chemical equation is a specific, representative statement about a chemical change. As an example, let's take a look at a representation of the decomposition of water into hydrogen and oxygen. In an equation, the left side will show the substances which are the reactants, and the right side will show the products resulting from the reaction. An arrow, known as a yield sign, points from left to right, indicating the reactants reacted and then yielded the products. Chemical equations also represent the relative quantities of both the reactants and the products in a reaction. Our example showing the decomposition of water cannot be considered an equation because it is not balanced. There is only one oxygen atom in the reactant, while there are 2 oxygen atoms in the product. For a chemical equation to be balanced, an equal number of atoms must be present on each side. Let's place a coefficient of 2 in front of the water. Now, our oxygen atoms are balanced on both sides, but the hydrogen atoms still are not. On the reactant side, we now have 4 hydrogen, and on the product side, only 2 hydrogen. To balance the hydrogen on the reactant side, we'll place a 2 in front of the hydrogen. Now, there are 4 hydrogen atoms and 2 oxygen atoms on both the sides. And we have a balanced equation. Let's balance a simple equation showing the combustion of propane as it yields carbon dioxide and water. Begin by balancing the number of atoms in the most complicated substance. In this case, it is propane. There are 3 carbon atoms in propane, so we'll put a coefficient of 3 in front of carbon dioxide in the product. There are 8 hydrogen atoms in propane, but only 2 in water. For that reason, we'll put a coefficient of 4 in front of the water on the right. That leaves us with 2 oxygen atoms on the left. But on the right, there are 6 in CO2 and 4 in H2O, adding up to 10, meaning our equation still isn't balanced. To end with a balanced equation, we need to put a coefficient of 5 in front of the oxygen atoms on the left. Summary. A chemical equation is a symbolic statement illustrating a chemical change. In a chemical equation, the number of atoms on the sides of the reactant should be equal to the number of atoms on the side of the product. To balance a chemical equation, first balance the compound with largest number of atoms.
Stoichiometric calculations. Stoichiometric calculations deal with the quantitative relationship between the reactants and products in a chemical reaction. The steps for solving stoichiometric problems are balancing the chemical equation, converting the units to moles, applying the mole concept and calculating the number of moles produced during the reaction, and finally, converting the number of moles of the required substance to the desired units. Stoichiometric problems are classified into mole-mole, mass-mass, mass-volume, and volume-volume relationships. Click each tab to learn more. In this type, for a chemical reaction, the number of moles of one of the reactants or products is calculated if that of the other reactants or products are given. Let's calculate the number of moles of carbon dioxide produced during the combustion of methane using 16 moles of oxygen. According to the balanced chemical equation, 2 moles of oxygen give 1 mole of carbon dioxide. Therefore, 16 moles of oxygen give 8 moles of carbon dioxide. In this type, for a chemical reaction, the mass of either one reactant or product is calculated provided the mass of the other reactants or products are given. Let's calculate the mass of magnesium oxide obtained by heating 30 grams of magnesium carbonate. According to the balanced chemical equation, 1 mole of magnesium carbonate gives 1 mole of magnesium oxide. 1 mole of magnesium carbonate is equal to 84 grams of magnesium carbonate, and 1 mole of magnesium oxide is equal to 40 grams of magnesium oxide. As 84 grams of magnesium carbonate gives 40 grams of magnesium oxide, 30 grams of magnesium carbonate gives 14.28 grams of magnesium oxide. In this type, for a chemical reaction, the mass or volume of either one reactant or product is to be calculated provided the mass or volume of the other reactants or products are given. Let's calculate the volume of hydrogen gas produced at normal temperature and pressure, NTP, when 65 grams of calcium reacts with water. According to the balanced chemical equation, 1 mole of calcium gives 1 mole of hydrogen. As 1 mole of any gas at NTP occupies 22.4 liters, 40 grams of calcium gives 22.4 liters of hydrogen gas at NTP. Thus, 65 grams of calcium gives 36.4 liters of hydrogen gas at NTP. In this type, for a chemical reaction, the volume of either one reactant or product is to be calculated provided the volume of the other reactants or products are given. Calculate the volume of oxygen required to convert 3.6 liters of nitric oxide to nitrogen dioxide. According to the balanced chemical equation, 2 moles of nitric oxide react with 1 mole of oxygen to give 2 moles of nitrogen dioxide. The volume occupied by nitric oxide is 44.8 liters and that occupied by oxygen is 22.4 liters. Thus, the volume of oxygen required to convert 3.6 liters of nitric oxide to nitrogen dioxide is 1.8 liters.
I hope now you had a clear idea about what are stoichiometric calculations or how to calculate the mass of the products formed, or also about balancing the chemical equations. Now when we take any chemical reaction that is happening, we know there are some amount of reactants that are reacting to give some amount of products. But what happens, there are situations where the amount of reactants required for that particular reaction may not be sufficient. I need say around 10 kg of reactant A and 20 kg of reactant B. But what happens, 20 kg of B will not be available to me. It will be only 5 or 10 kgs that will be available. So what impact does it create? It will affect the amount of product that is formed. Are you able to understand, children? If I want a good amount of product, I need to have the right amount of reactant. If I don't have the required amount of reactant, I may not get a good yield of product. So this is what is called as limiting reagent. When I take a chemical reaction, there are situations where the reactant will be available in lesser amount. The reactant will be available in lesser amount. So what happens? It will get consumed very faster. The reactant, say we have 2 reactants A and B. B is very less in amount, so it gets consumed faster. So when it gets consumed faster, the reaction will stop. Once all the B gets over, there is no reaction taking place. So B will be called as a limiting reagent. The reactant or the reagent which is present in lesser amount, that limits the reaction or that limit the amount of product formed is called as limiting reagent. Now we will be doing one problem. Just listen carefully, children. It's there in page number 19 of your textbook. I'll read out the question. 50 kilogram of nitrogen and 10 kilogram of hydrogen are mixed to produce ammonia. So what is given to us? Given to us is 50 kilogram of nitrogen and 10 kilogram of hydrogen. These two are mixed to produce ammonia. And what is the question? Calculate the ammonia formed, identify the limiting reagent in the production of ammonia in this situation. So first it is given in kilograms. First I need to find out the number of moles of nitrogen and hydrogen, right? I should calculate the moles of nitrogen and hydrogen. What is the formula for calculating the number of moles? We know number of moles is equal to mass in grams by gram molecular mass, because these two are molecule, these are not atoms. So this mass in grams, the given mass is actually given in kilograms. So what should I do? I should convert that into grams. How will I convert kilogram into grams? I will multiply by 1000. So what do I get? 50 into 1000, that is the given mass, divided by GMM of nitrogen. How much is GMM of nitrogen? 14 is for GAM. So double of that, which is 28. So 50 into 1000 by 28. What is the answer they have given? 17.86. 17.86 into 10 power 2 moles. This is the number of moles of nitrogen. Now how do I calculate the moles of hydrogen? Moles of hydrogen. How will I calculate? Moles of hydrogen will be, that is 10. So 10 I have to convert into grams. So 10 into 1000 by, it is 2.016, because 1.008 is the atomic mass of hydrogen. So since it is H2 molecule divided by GMM. What is the amount given there? It is around 4.96 into 10 power 3 moles. 4.96 into 10 power 3 moles of hydrogen. So this is what we got from the question. What is given in the question to us? 50 kilogram of nitrogen, 10 kilogram of hydrogen. They both combine together to produce ammonia, right? So we need to calculate the amount of ammonia formed and also identify the limiting reagent. Now what is the first step? I will convert my kilogram into grams. So I am converting by multiplying with 1000. Why I am converting into grams? So that I can calculate the number of moles of nitrogen and hydrogen. Now once I calculated, what is the equation for the formation of ammonia? Formation of ammonia is nothing but N2 plus 3H2 will be giving 2NH3. This is the equation for the formation of ammonia, chemical equation. From this, what do you understand? 1 mole of nitrogen. Here 1 mole of nitrogen needs how many moles of hydrogen? It needs 3 moles of hydrogen. See children, the number which is present before the reactant is the moles. This we have studied in 10th standard. The number of moles that is taking part in the chemical reaction. So in this it is given 1 mole of nitrogen needs 3 moles of hydrogen. So how many moles did we calculate here? 17.86 moles of nitrogen need how many hydrogen actually? So that we will calculate by 17.86 into 10 power 2 into 3 divided by 1, right? This is 17.86 into 10 power 2. Okay. So how much we got? It is around 5.36 into 10 power 3 moles of hydrogen. You are able to understand children? From this equation, 1 mole of nitrogen needs 3 mole of hydrogen actually to combine. But I have got 17.86 moles of nitrogen which is present in 50 gram of nitrogen. So this 17.86 moles of nitrogen needs how much hydrogen? That we are calculating by 17.86 into 3 divided by 1, which is 5.36 into 10 power 3. So to produce ammonia, I need 5.36 into 10 power 3 moles of hydrogen. But how much I have? With 10 kg of hydrogen, I have only 4.96 into 10 power 3 moles of hydrogen. The required amount is 5.36, but from calculation I got only 4.96. So which is the limiting reagent? Yes, you are right, dihydrogen, that is H2 is the limiting reagent, because out of 5.36 I have only 4.96 into 10 power 3 moles of hydrogen. Now what is the next step we need to do? Now we need to know that 3 moles, that is 3 moles of hydrogen will give 2 moles of ammonia, right? 3 moles of nitrogen is giving 2 moles of ammonia. So 4.96. So 4.96 into 10 power 3 moles of hydrogen will give how much ammonia? It will be cross multiplied, right? 4.96 into 10 power 3 into 2 divided by 3. You are able to understand? First we calculate how much moles of hydrogen is required for the reaction to occur. We need 5.36, but from the calculation we came to know we have only 4.96. With 4.96 now the question they have asked is calculate the ammonia formed. So with 4.96 into 10 power 3 moles I need to calculate how much ammonia will be formed. From the equation again we should understand that 3 moles of hydrogen will be giving me 2 moles of ammonia. So 4.96 into 10 power 3 moles of hydrogen will give 4.96 into 10 power 3 into 2 divided by 3. Now what is given that? It is around 3.30 into 10 power 3, that is 3.30 into 10 power 3 moles of ammonia. This much ammonia will be formed, yes. But this is actually given in moles to us. You can use a calculator, children, when you are doing this in your exam. Okay. So we got the number of moles of ammonia formed. But in our question, they haven't asked about the moles, but instead the question was they are asking about the amount of ammonia formed. So how do I calculate? To calculate the amount of ammonia, I should convert the moles into grams. That is 1 mole of ammonia is equal to 17 grams, right? So 3.30 into 10 power 3 moles of ammonia will be equal to 17 into 3.30 into 10 power 3. Understood, children? Which is around 56.1 into 10 power 3 grams, correct? Or I can say 56.1 kilogram of ammonia, because the question is given in kilograms. Understood now, children? It is very easy. When an equation is given, calculate the number of moles, find out the required number of moles, see which one is limited in the given question, identify the limiting reagent, then calculate the product formed. With the product formed, you will be knowing to calculate the amount of the product which has been formed in the reaction. You are able to understand, children? This is with respect to limiting reagent. Now we will be learning about reactions in solutions. Why do we take solutions? Because there is some solvent in which some amount of solute is being dissolved and you get a solution actually. Now whenever we talk about solution, it can be concentrated, it can be dilute, but what does it depend on? That is the concentration of the solute or the concentration of the solvent, or together I say concentration of the solution, right? That is all depending on the amount factor, that is how much or the quantity is present, that is the percentage, the content, so which we call it as quantitative analysis. So here we have some 4 methods to calculate the amount or the concentration of the solutions. First one we will be seeing about mass percentage. When I say mass percentage, it is nothing but using an equation where you are going to calculate the mass percent by dividing the mass of the solute by mass of the solution into 100. This is the formula. These type of questions can come for your board exam. You can just refer the textbook questions, that is more than enough. Okay. So mass of the solute by mass of solution into 100. Let me just do an example for you. A solution is prepared by adding 2 gram of substance A in 18 grams of water. calculate the mass percentage of the solute. How do we do this now? So this is my solute, this is my solvent. When I add this solute to my solvent, I get my solution. So what is my mass percent? Mass percent will be mass of the solute, which is around 2 grams. So I put 2 in the numerator divided by mass of the solution. What is solution? Solution is nothing but solute plus solvent together, right? So I put this 2 grams plus I take this 18 also. 2 by 2 plus 18 into 100, which is 2 by 2 plus 18 is 20 into 100. So 0, 0 cancel. Here 2 5s are 10, which is 10%. So what is the mass percent of solute A? Which is 10%. That's all you need to do. So now you came to know that mass percent is nothing but mass of the solute by mass of the solution into 100, where my solute is present in smaller amount. This is my solvent in which I dissolve my solute. Together it will make me a solution. You are able to get me, children? I have given one more question. Let us see how to do that. A solution is prepared by adding 4 grams of a substance A. So 4 grams is my solute, which is added to 46 grams of my solvent, which is ethanol. C2H5OH is ethanol. So 4 grams A is added to 46 grams of my ethanol. Calculate the mass percentage of A. Again, similar question. How do I calculate my mass percent? Mass percent will be mass of the solute, which is now here 4. So I put 4 on the numerator divided by 4 plus 46. Solute plus solvent, 4 plus 46 into 100, which will be 4 by 50 into 100. What happens here? 5 0 0, 5 1s are 5 2s are. So 4 2s are 8%. This will be the mass of my solute A, which is dissolved in the solvent. You are able to follow me, children? This is how we are able to find out the mass percentage. When I say mass percentage, it is nothing but the amount. So that shows whether the solution is concentrated or it is dilute. Now we will get into the next method, which is mole fraction. In a classroom, we have 50 children. What fraction of girls are present in the whole class? So it can be 1/3 of the whole class, it can be half, or it can be 3/4. So mole fraction means when I say A is one of my solute, B is another solute, A and B together they make a solution. You are able to follow me, children? A and B together they make a solution. Now if I have to find out what is the mole fraction of A in the solution, then I will calculate what is the mole fraction of B in the solution. So when I say 50 children again and I say 20 are girls, so how much will be the boys? 50 minus 20 will be my boys. So if I get my A, so the mole fraction, total mole fraction will always be equal to 1. That is mole fraction of A plus mole fraction of B will be equal to 1 together when you add it. So once I get mole fraction of A, 1 minus mole fraction of A will be mole fraction of B. You are able to get me, children? Now how do I do this? Mole fraction of A will be number of moles of A divided by number of moles of the solution. What do you mean by that? I calculate the moles of A, then I calculate the moles of B. So number of moles of A divided by number of moles of A plus number of moles of B will be giving me the mole fraction of A. That is, how do I calculate the moles of A or B given mass by GAM or given mass by GMM? That is how I get the moles of A. Similarly, I get the moles of B. So when I add A and B, I get the moles of the solution. So out of which, how do I get the mole fraction of A? In the whole solution, what is the fraction of A present? So that will be moles of A by moles of solution. Similarly, for B mole fraction, it will be moles of B by number of moles of the solution. Till now we haven't got any problem with mole fraction in the exam. Let us see for this year what is going to happen. Anyway, once this lesson gets over, we will be doing the practice problem in the mole fraction. Okay. Now we will get into the last part of this chapter, that is molarity and molality. Molarity. M-O-L-A-R-I-T-Y. Molarity will be denoted by capital M. What does molarity means? We used to say molar solution, 1 molar solution, 2 molar solution. If you come to 12th standard, you will be hearing this word again and again, molar. What is molar actually? Molar or molarity means the number of moles of solute. What is my solute? Something which I am going to add in less amount. The number of moles of solute in volume of solution in liters. Solution is again a combination of solute and solvent, but I am going to take in liters, that is in 1 liter of the solution, how much moles of solute is being added, that will be giving my molarity. You are able to get me, children? Now, let us consider a simple example. I have 1 molar of sodium hydroxide. Please listen very carefully. I have 1 molar solution of sodium hydroxide. What does it mean? It means I have 1 mole of NaOH. I have 1 mole of NaOH which is dissolved in 1 liter of solution. That is giving my molarity. That is, I have 1 mole of NaOH which is divided in 1 liter of my solution, which will be giving 1 m of sodium hydroxide. You are able to understand me, children? Yes. Now, if I want to prepare 0.2 molar of NaOH, if I need to prepare 0.2 molar of NaOH, what I need? I need 0.2 moles of NaOH in 1 liter solution. Am I right, children? I want 0.2 moles of NaOH in 1 liter solution. That will make 0.2 divided by 1, which is 0.2 molar. But if 1 mole is dissolved in 1 liter of NaOH solution, it is okay. 0.2, can it be divided in 1, can it be dissolved in 1 liter solution? That makes the concentration of the solution a big difference. So what should I do now? To calculate how much volume of NaOH I need so that I can make up the solution to 1 liter. That is, I take the required amount of NaOH, then start adding water so that I make up the solution dilute to make it to 0.2 moles. What should I do? For 0.2 moles, I need to calculate the volume of NaOH required. How do I calculate? Very easy. 1 mole, you need 1000 ml. That is what we calculated here, right? 1 liter is nothing but 1000 ml. So for 0.2 moles, how much ml of NaOH I need? 0.2 into 1000, which is 200 ml. So if I dissolve 0.2 moles in 200 ml of NaOH plus 800 will be my water. If I dissolve that in this solvent, I get my 0.2 molar of NaOH solution. You are able to get me? Now we will do one problem for you to understand. Okay, children? What is molarity? If this you can copy in your notebook also if you want, because problems are very important. Okay, don't, you can easily score marks in that. What is the question given? Calculate the molarity of NaOH in solution prepared by dissolving 4 gram in enough water to form 250 ml of the solution. Now the question is very clear. They have given 4 grams of NaOH, right? And what they have given? 250 ml of solution. So what should I do now? First I need to calculate my moles, because molarity is equal to number of moles of solute dissolved in volume of solution in liters. 4 grams of NaOH is given. So for moles of NaOH, I need to calculate the moles of solute. So to calculate moles of NaOH, how do I calculate? Mass in grams by GMM. So it is 4 divided by, what is the GMM of sodium hydroxide? It is 40 grams. How do I get 40 grams? Sodium is 23, oxygen is 16, hydrogen is 1. Together it will make 40 grams. So 4 divided by 40, which is 0.1 moles. Okay. Now once you get your 0.1 mole, I should divide that in, this much is the solution given, total solution. So I will calculate M is equal to 0.1 divided by, can I put 250 ml there? No, it should be in liters. So it will be 250 by 1000, which is 0.250, right? Number of moles of solute divided by volume of solution in liters. This has become liters now. How much is the answer I am getting? 0.4. 0.4 moles per liter. This is my molarity, or simply you can put 0.4 capital M. Understood, children? Instead of sodium hydroxide, you can get any compound where you can calculate the moles first divided by the volume. If volume is already in liters, you need not do anything. If it is in milliliters, convert into liters and then do the calculation. Now we will get into molality. What is molality? Something that is similar to molarity, but in molarity we were focusing on solution. See children, not only molarity, when you take mass percentage, when you take mole fraction, whichever you take, you consider the solution part in your denominator. If you see any problems that we take, solution part will be considered in the denominator. But here in case of molality, always the solvent part comes at the denominator, right? You don't write solution, instead we write the solvent, and that too it is mentioned in kg, that is mass of the solvent in kilograms. So what is the formula for molality? Number of moles of solute divided by mass of the solvent in kg. Now what is the question given? The density of 3 molar solution. When I say 3 molar solution, we know 3 moles of solute is dissolved in 1 liter of the solution. So 3 m of sodium chloride is 1.25 grams per milliliter. Density is given, molarity is given. They are asking us to calculate the molality. How do we do? Molality is given. I need to find out the mass of NaCl which is present in 1 liter. Because we got the moles, but we need to calculate the mass. How do I calculate? 3 into the GMM of NaCl. What is the GMM of NaCl? It is 58.5 grams for sodium and chlorine together, which makes to 3 into 58.5, which is 175.5 grams. So NaCl is dissolved in water. So how much is the mass of NaCl? It is 175.5 grams. Now what is mass of 1 liter of solution? If when I say 1 liter of solution, it will have my sodium chloride and water together. But mass of 1 liter of solution is nothing but density is given as 1.25. We know density is mass by volume. So what will be the mass of the solution? Mass equal to volume into density. Volume we know it is 1 liter, which is 1000 ml. Density is given as 1.25 gram per milliliter. So when I multiply these two, I get the mass of my solution. I get the mass of solution, I got the mass of the solute. How will I calculate the mass of the solvent? Because I need the mass of solvent here. How will I calculate? Salt plus solvent is solution. So, solution minus solute will be giving the solvent. So, 1250 minus 175 will be giving me the mass of the solvent. So, now I got the moles as 3 moles. So, 3 moles divided by the mass of the solvent will be giving my molality. It is very easy, though it is given in 2 lines the questions, you need to calculate some more deep into so that you get the final answer. So, when we practice more questions, we will have more idea to do better. Definitely, the chapter is already got over now. I will be doing a recap before I get into the second chapter. The recap will be doing all the important things again, children. Okay, at least for 10-15 minutes we will do that, then we will get into our new chapter. So, I want you all to do the homework. I will be sending you through WhatsApp. That empirical formula, actually in the video only 2-3 questions are there. Some children have done it and have sent to me. I want you to see the video again so that you get it, children. Okay. So, I think you will not have any doubt till now. I hope you enjoyed the class. I will be posting a video, I told you, to understand much better about this. So, be safe, stay home, stay healthy. Take care, children. See you in the next class. Bye.
Molarity of a solution. Molarity and molality are units used for quantifying the concentration of a solution and are based on the mole. In this session, we'll concentrate on learning how to calculate molarity. 1 mole is the amount of a substance that contains 6.023 multiplied by 10 to the power 23 entities of that substance. For example, 1 mole of carbon will contain 6.023 multiplied by 10 to the power 23 atoms of carbon. 1 mole of carbon dioxide will contain 6.023 multiplied by 10 to the power 23 molecules of carbon dioxide. And 1 mole of sodium chloride will contain 6.023 multiplied by 10 to the power 23 ions of sodium chloride. Molarity is defined as the number of moles of a solute in 1 liter of a solution. For example, a 0.20 molar NaCl solution will contain 0.20 moles of sodium chloride in every liter of the solution. Consider a solution composed of 10 grams of sodium hydroxide in 200 ml of water. Let's see how to calculate its molarity. First, we need to calculate the number of moles of solute, which is sodium hydroxide, that are present in the solution. The atomic mass of sodium is 23, of oxygen it is 16, and of hydrogen it is 1. Adding up the 3 atomic masses will give us the atomic mass of our compound, which will be 40. We already know that there are 10 grams of sodium hydroxide in the solution. The number of moles of sodium hydroxide in our solution can be derived using the equation 10 multiplied by 1 mole of sodium hydroxide divided by 40, which gives us 0.25 moles of sodium hydroxide. Next, we need to calculate the number of liters of the solution. We already know that we have 200 ml of solution, but we need it in terms of liters. So, 200 multiplied by 1 liter of water divided by 1000 ml will give us 0.20 liters of the solution. Finally, we have to divide the number of moles of solute by the number of liters of solution. In our example, the number of moles of solute is 0.25 and the number of liters of solution is 0.20. 0.25 divided by 0.20 will be 1.25. From this, we know that the molarity of sodium hydroxide in our solution would be 1.25 moles per liter. Summary. Molarity is defined as the number of moles of a solute in 1 liter of solution. The steps for calculating a solute's molarity are: calculate the number of moles of solute. Calculate the number of liters of the solution. Divide the number of moles of solute by the number of liters of solution.